All right, so chapter 20 is all about discrete random variables. This very first section is actually pretty straightforward. It's just kind of introducing you to the concept of random variables. So, for example, the opening problem is a game at a carnival and how much you can win. So, it gives you this table here, gives you kind of the prize value, the probability of winning each one, and the things like that. All right. So, how do we distribute the probability? That's what's really going to be important in this chapter. So, first of all, go ahead and get your definitions copied. A random variable uses numbers to describe the possible outcomes that could result from a random experiment. All right. I'm going to actually write down capital X because a discrete random variable X has a set of distinct possible values. Discrete just means exact. A continuous random variable X can take any value on some interval. Continuous just means there's a range of values. Usually that's for like measurement. So here's the discrete examples. Here's the continuous examples. Usually it's things we need to measure. Okay, so I want you to think about a supermarket has 3 checkouts, A, B, and C. An inspector wants to check the weighing scales for accuracy. So we're going to assign the random variable X as the number of accurate weighing scales. All right. So I'm going to make a little table kind of just organizing all the possible outcomes. So we have checkout A, B, and C. And let's say that A is for accurate, N is for not accurate. So all 3 of them could be accurate when the inspector comes through. That's one possibility. Maybe only 2 of them. So maybe A is not, but B and C are. A is accurate, B is not, C is accurate. This is where only 1. So A is accurate, B is accurate, C is not. What if only 1 of them is accurate? So let's say A is accurate, the other 2 are not. B is accurate, the other 2 are not. C is accurate, the other 2 are not. Or maybe none of them are accurate. So that's all the different possible outcomes the inspector could find. So what does each corresponding X value mean? If X is the number of accurate weighing, here, what does X equal if all 3 are accurate? X is 3. There's 2 accurate. So X can be 2 here, X can be 2 here. So I'm just going to make my way down, showing what does X equal for each situation. So in general, X can either be 3, 2, 1, or 0. And these are all the different ways that it can happen. So what corresponds to exactly 1 accurate scale is when X equals 1. What if it just wants at least 1? That means X could be 1, because that's 1 or more. It could be 2. It could be 3. So this is, section A is really just kind of laying out this whole random variable X. And whenever you see a capital X like that, it's telling you it's a random variable. You've got to find all the possibilities, and then you list all the different corresponding X values. So you just want to kind of play around with that a little bit.